Hey guys, Dr. Brown here with Kubo Math coming to you from Tarlac City, Philippines. And tonight we're doing definite integrals. So this is a Calculus 2 class, and so let's get after it. Okay, you know the fundamental theorem of calculus says if I have a continuous function or a function that's continuous on AB, and the antiderivative of f of x dx, the integral of that from a to b, and the integral of that is big F, if you will. So we have the little f. I'll use some crazy terms here. So if this large F indicates the antiderivative of this function, then it ends up being big F of b minus big F of a. So that would be the resulting definite integral results. Now, we've seen this before in one of our other classes, but how does that work for us? We haven't performed that many definite integrals, so let's just work a simple one here first just to see how this works out. Okay, so we have the integral of from 0 to 2 of 6x dx. So we'll work this same as we've done in the past, except we're going to plug the integrals in. Oh, and I should say, when we had the integral of f of x dx from a to b, I'm going to leave this up here. We had f of b minus big F of a. All right, let's keep that in mind for what we're about to do. All right, we're going to go 6x to the 1 plus 1 equal 2 divided by 2. Okay, so that's 6x to the second divided by 2. And that equals what? 3x squared from 0 to 2. Now, early on, it would be good for you to take and make two boxes. Just like that. And what this indicates is in this first box is f of b. So everything associated with f of b or b is going to be in that first box. Everything associated with a is going to be in the second box. Okay, so what do we have in the first box? We're substituting in 2 for x. So we have 3x, I'm sorry, we're substituting 2 in for x. 2 squared, 3 times 2 squared. Okay, that was f of b. Now f of a, so now we have 3 times 0 squared. Now we're doing a simple one first. And actually none of these, not any of them are too difficult at all. So 2 squared is 4, 3 times 4 is 12. 12 minus 3 times 0 is 0, so the results of this is 12. But the key there was looking at f of b minus f of a. And this becomes important when you end up with my kryptonite, like minus a minus, things like that. This helps keep up with the sign and what should be in the box. Especially when you get to this one, you'll see exactly what I'm talking about. Okay. One down. Let's pick another one here. 3. The integral from 1 to 2 of 3 over x to the second power minus 1 dx. Okay. Let's rewrite that and bring the x up to the numerator. So it's integral from 1 to 2 of 3x to the negative 2 minus 1 dx. Now let's do our thing here. Well, I don't need that sign anymore. We'll just do it here. Negative 2 plus 1 is going to be, so add 1 to that gives me a negative 1. I'm going to divide by that. So I end up with a negative 3 over 1, or just a negative 3. I'll just drop the 1 here. Over, or excuse me, x to the minus 1. Negative 3x to the minus 1. Minus the integral of negative 1 would be a negative x. So let me rewrite this thing, and negative 3 over x minus x from 1 to 2. Okay, what about those two boxes we talked about? And you can kind of see I have multiple terms here. And back in the day when I first started doing this, I might put the 2 in for here and I would put the 1 in for that, thinking I'm doing this. And that's just not correct. You want this negative 3 over x minus x here with b. And then negative 3 over x minus x in here, substituting 1 in for x. So you end up with negative 3 over 2 minus 2. So I plugged in b for those two x terms, minus now negative 3 over 1 minus 1. Okay, so what do we have here? Let's get up here. Negative, I'll just copy this back down. Negative 3 over 2, that's in my first box, minus negative 3, I'll drop the 1 in the denominator, minus 1. Okay, what do we have here? Negative, well, let's get us a common denominator in this first one. So I have a 2 in the denominator, minus 3 over 2. And I need to multiply this one by 2 over 2, so that gives me negative 4 over 2. Minus, oh, there's my kryptonite. Minus a minus is plus 3. Negative times negative is plus 1, so that gives me a 4. All right, so I have a negative 7 halves plus 4. Well, let's get another common denominator. Let's put it over 2. So I have 2 over 2 times that one. So negative 7 over 2 plus 8. 4 times 2 is 8. 8 over 2. So that gives me a positive 1/2. So that integral we started with, the results of that, going from 1 to 2 of 3 over x squared minus 1 is 1/2. You can see in this problem, since we had something like this, the two boxes help us organize that. You won't do that forever, for sure. But it really helps early on. Actually, as you get older like me, it still helps. All right, let me erase that guy so I don't repeat it. All right, let's work a few of these here, get them out of the way. All right, you'll notice we have the integral from negative 8 to 8 of the cube root of x dx. So let's rewrite the cube root as x to the 1/3. So now we have the integral from negative 8 to 8 of x to the 1/3 dx. Okay? So what does that equal? Well, I don't need this integral sign, we'll just do it up here. So x to the 1/3 plus 3 over 3, which is 1. So we're adding 1, that equals 4 over 3. So I have x 4 over 3 to the 4/3. Now I'm dividing by that. So I'd have to divide by 3/4. And that's going to be from negative 8 to 8. Okay. Well, what does that equal? I need to put my two boxes here. All right, 3/4. Now obviously I could factor the 3/4 out. Sometimes I don't, because if the problem gets really long, I might lose sight that I had some number in the beginning I needed to multiply by. But that's just me. All right, so I need to put 8 in here. 8 to the 4/3. So 3/4 times 8 to the 4/3 minus 3/4 negative 8 to the 4/3. If you plug that in your calculator, it explodes. Actually, it goes into a complex number. Okay, let's think about this. We have 3 over 4. I'm going to write that down so I don't lose them. And I'm going to deal with this 8 here. I guess I should have put that here. I've got 8, the cube root of 8. So this 8, I really could look at this one as 8 to the 1/3 to the 4th power. You remember the rule? A to the m raised to the n equal a to the mn. Okay, so we have 4 times 1/3 here, or 1/3 times 4. That's how I'm looking at that. So the cube root of 8, 2 times 2 times 2, so it's 2. 2 raised to the 4th power. 2 times, so the 1/3 power of 8 is 2. So now I have 2 to the 4th. 2 times 2 is 4, times 2 is 8, times 2 is 16. So this comes out to be 16. So that's 16. Guess I better put that back inside here. All right, let's take this guy and say, well, I'm going to take the -8 and raise it to the 4th power, and then take that to the 1/3 power. Now my logic here was, if I raise that negative number to a positive, the negative goes away to a positive power. So -8 times -8, that gives me a positive number, right? And then that next two -8s times -8, those give me a positive. So a positive times positive obviously is positive. So the results of this would be positive. And then if I take the cube root of that results, I also end up with 16. I end up with the same number I had here. So a minus a gives me 0. So I don't have to take the time to multiply all this out. So what's in this parentheses is the same that's in this one. So the results of this integral is 0. And we used a few different rules to get there. I'm a rules guy. The rules, when I went through college, really helped me. I kept a notebook actually when a new rule would come out in calculus or physics or trig or whatever it happened to be. I had these just pieces of paper. I thought, wow, that's a good rule, and I'd write it down in this actually it started out to be a notebook, and it finally had gotten full, and so I ended up with just a big, like a clipboard full of just all these formulas. So if we had an open book test, whoa, I didn't have to thumb through my book to find, well, where is that formula? It was right there in that little clipboard, and it proved to be valuable. So even to this day, as I go back and study, I do keep a notebook on different rules. It helps me wrap my mind around what to do. I don't know how anybody can operate without them. All right, let's get over here a little bit with this one. So the integral from 1 to 3 of 4x cubed minus 3x squared dx from 1 to 3. All right. Okay, let's take and add 1 to this one. So that gives me 4. We're going to divide by 4. These 4's cancel. So I have x to the 4th power minus, this is 2 plus 1 is 3. Divide by the 3, that cancels. So it's minus x cubed from 1 to 3. Okay, so now I have, well, put my little boxes up here. So I have x to the, or 3 to the 4th minus 3 to the 3 cubed. See how this is coming in handy? Because if I didn't have those boxes, I might have just stuck this over there and put the 1 in it. Now I would have ended up with 3 to the 4th minus this other, and just lost some things. Now, and it just may have been wrong. Okay, so now, of course in this case maybe not, but you'll see in a moment why. All right, in this case, 1 to the 4th minus 1 to the 3rd. That's why this may have worked out, even though it would have been done incorrectly. This goes to 0. Okay, 3 times 3 is 9. 9 squared would be 81. Minus 3 cubed is 27. That's 54. Okay, so that integral is x 4x cubed minus 3x squared. Just can't tell what that is anymore, but anyway, that comes out to be 54. So what does that indicate? That's the area under that functional curve. That's what all of these are. It's just the area under whatever the function is. All right, let me grab a different marker. This one is getting mad at me and not wanting to write. All right, let's see what we got going on now. All right, now we have the integral of the cube root of t minus 2 dt from -1 to 1. All right, let's rewrite that one. -1 to 1, t to the 1/3 minus 2 dt. And, well, we'll calculate it right here. All right, t to the 1/3 plus 1, which would be 3 over 3. So that equals 4 over 3. So 3 to the 4. So let's write that one down. T, 3 over 4 times t to the 4/3 minus 2t. We integrate the constant 2. We get, and with respect to t, we get a t here. And that's from -1 to 1. All right, let's put our two boxes here. What goes in here? Big F of B. What goes in there? Big F of A. This is B, this is A. All right, we have 3/4 t to the 4/3. 1. 1 to the 4/3. I can do that one. 1. Okay, minus 2 times 1, which is 2. I'll go ahead and put the 1 there. All right, minus 3/4 times -1. Oh boy, here we go again, to the 4/3. Minus 2 to the -1. Oh boy, what do we have? All right, 3/4 minus 2. I tell you what, let's just keep it here. 3/4 times 1 minus 2. All right, -1 to the 4th power gives me 1. 1/3 of cube root of 1 is still 1. So I end up with a positive 1. 1 times 3/4 is 3/4, but I have a negative. So I'm going to say minus 3 over 4. Okay, and then 2 times -1 is a -2. -2 times this gives me a positive 2, but this gives me a minus 2. Whoa, what do we have? 3/4 minus 3/4. Those cancel. -2 minus a positive 2 is plus a negative, and that equals a -4. So that integral from -1 to 1 of the cube root of t minus 2 gives me a -4. Okay, so far so good. Whoa, here's a kind of a cool one. All right, integral from 0 to 2 of 2 minus t times the square root of t dt. Well, don't let all the t's in that freak you out. Let's just distribute this t into that. Now, let's rewrite it first. 0 to 2 of 2 minus t times t to the 1/2 dt. Now, what's the rule? Well, obviously t to the 1/2 times 2. Hey, we can do that one. 2t to the 1/2. But if I have a to the m times a to the n, well, that equals a to the m plus n. Okay, so I have the same situation here. I have t to the 1 times t to the 1/2. And that equals t to the 1 plus 1/2. Well, that equals 2 over 2, drop my t, plus 1/2, and it equals t, my t keeps running off there, t to the 3/2. Okay? All right, and I have a negative here, so it's minus t to the 3 over 2. So that's my integral from 0 to 2 dt. And all I've done is distribute the t to the inside using the distributive property and one of the rules of exponents. All right, rules, rules, rules. All right, let's add 1, which is 2 over 2. That equals 3 over 2. I've got to divide by that, which is 2 over 3. So 2 times 2 is 4. So I have 4 over 3t to the 3/2. Minus, I've got to add 2 over 2 to that one, which gives me 5 over 2. Now divide by 2 over 5. So minus 2 over 5 t to the 5/2 from 0 to 2. Wow, we are cooking with grease now. All right, so let's put our boxes out here because we've got a lot going on here. All right, 4/3 t, 2 to the 3/2. I have 2 raised to the 3/2 power minus 2 over 5 t. I'm still in f of b, big F of b. 2 over 5, 2 to the 5/2, 2 to the 5/2. Minus, oh, this is good, 0 times here and 0 times there. That gives me 0. All right, so let's move all of this up where we can see what's happening. 4/3 is in my first box. 2 to the 3/2 minus 2 over 5, 2 to the 5/2. We just had 0 out there. I'll put it there so we won't forget that we had it. Okay, 4/3. 2 to the cube power. 2 times 2 is 4, times 2 is 8. The square root of 8 is what we're dealing with here. Okay? Minus 2 to the 5th. 2 times 2 is 4, times 2 is 8, times 2 is 16, times 2 is 32. And now we're trying to take the square root of 32. All right, 4/3. We've got the square root of 2 times 4 minus 2 over 5 times the square root of 4 times 8, but 8 can be listed as 4 times 2, such that that becomes 2 over 5 times the square root of 16 times 2. This is 4/3 square root of 2 times square root of 4. This would be square root of 16 times square root of 2. Because you recall the rule, a times b, square root of that equals square root of a times square root of b. So that's why we can do that. Okay. So what do I have? I have 4/3. Square root of 2 is 2. 2 square root of 2. Minus 2 over 5 times 4 square root of 2. So I have 8 over 3 square root of 2 minus 8 over 5 square root of 2. Well, let's get a common denominator. Can you still see that? All right, 15. Well, 3 will go into 15 5 times. Let me multiply that side by 5 over 5. 5 times 3 is 15. 5 times 8 is 40. 40 times square root of 2 minus, this is going there 3 times, so I need to multiply that by 3 over 3. 3 times 5 is 15. 3 times 8 is 24. 24 square root of 2. All right, that would give me 40 square root of 2 minus 24 square root of 2 is 16 square root of 2 over 15. You can see, at least for me, the boxes help me keep it organized. Now, one of them fell away. Then some old school square roots there. All right, the integral from 0 to 2 of 2 minus t times the square root of t dt equals 16 square root of 2 over 15. This is a nice little problem. These are the problems that are just the beginning of understanding how to work the fundamental theorem of calculus. Taking the integral of f of x, little f of x, ending up with a antiderivative, big F of x, and then big F of b minus big F of a. I don't know if the mathematicians, when they hear big F and well, what's that guy saying? If you can't have fun, there's got to be something to help you remember what to do. Let's now shift gears just a little on a couple of problems and go through and work an integral of trig functions. Integral from 0 to pi over 4, okay, of 1 minus sine squared theta over cosine squared theta d theta. Now it's super important, and you see this on YouTube with everybody, I mean every mathematician out there, and they're right. Understand your derivatives and understand identities. It's imperative. You have to do that, and it's quite a bit to remember. But the way to remember it, keep working problems. Practice, 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 practice. Okay, you can look at this one. Well, sine squared, for example, sine squared theta plus cosine squared theta equals 1. Well, I could subtract sine squared from both sides. Cosine squared theta equals 1 minus sine squared theta. Oh, look at what I have in the numerator. I can replace that with cosine squared theta. So now I have the integral from 0 to pi over 4 of cosine squared theta over cosine squared theta. Oh, d theta, this is looking better all along. Well, that just becomes 1. So now I have the integral from 0 to pi over 4 of d theta. 1 times d theta, and that integral equals theta, and I'm integrating that, or looking at the limits of 0 to pi over 4. Well, I have my little 2 blocks here. What goes in the first one? Pi over 4. What goes in the second one? 0. Pi over 4 minus 0 equals pi over 4. But that was made possible by knowing some identities here. It's important. And to understand these, maybe look around trig on a unit circle. So it helps you with some of those. All right. One last one. We have the integral from minus pi over 3 to pi over 3 of 4 secant theta tangent theta d theta. Now this is where you need to know your derivatives. The derivative of secant theta is secant theta tangent theta. So the integral then, if I go from derivative, if I go from secant theta, I take the derivative of that with respect to theta, I end up getting secant theta tangent theta. Well, if I integrate this with respect to theta, I go back that way. So the derivative put me to secant theta tangent theta, derivative of secant. Now the integral then of secant theta tangent theta puts me back at this is secant theta from minus pi over 3 to pi over 3. Well, so what does that end up being? Secant of pi over 3 minus secant of minus pi over 3. Okay, but if I have let's let this be pi over 3. So that's a 60-degree angle. So I have square root of 3, 1, 2. Okay, so cosine, which is the opposite of secant, cosine is 1 over 2. So make certain I've done that correctly, because I always do this with a 30 degree. It's 1 square root of 3 over 2. So cosine is 1/2, so cosine 1/2, yep, that's good. Or cosine of that angle would be 1 over 2. Cosine, well, that's right. Okay. All right, so secant of pi over 3, instead of cosine, it's the opposite. It's not adjacent over hypotenuse, it's hypotenuse over adjacent. So the secant of pi over 3 is 2 over 1. Minus, now, you know on the unit circle, you have 4 quadrants. All students take calculus. If you're in the 4th quadrant, which a negative 60 or negative pi over 3 would be, it's still, cosine is positive. So this is positive also. Oh, and I forgot my 4 here. Sorry, 4 secant this. I just noticed that. So all student takes calculus is saying that all the functions are positive here. Sine functions are positive here. Tangent are positive here. Cosine functions are positive in the 4th quadrant. So this minus pi over 3 or negative 60 degree is still 2 over 1. So 2 over 1 minus 2 over 1 equals 0. So that integral from negative 60 to positive 60, or negative pi over 3 to positive pi over 3 of 4 times secant tangent theta is 0. Okay, these were just a few examples of definite integrals, and trying to get, again, more practice under our belt, keep working some, keep study. I'll say it every week. Learn your derivatives too. If you can know your derivatives, as we worked a few problems with the trig identities, and understanding, you know, the derivative of secant gave me this, then the integral of that gives me secant theta. So that allowed me to work that problem, which in my mind would have been unworkable before. I guess you could have changed these into sine over cosine, 1 over cosine, and went at it from that perspective. But that's kind of like reaching around the back of your head to scratch your elbow. Okay, that's enough for now. Why are we doing this? Because together we want to build a better tomorrow, and we want to do that through math. So study, and we'll talk to you next time. Thanks.